Welcome. So in this video we will cover a numerical on standardization of milk meant for cheese making, and this is the problem number 10 in the book Outlines of Dairy Technology by Sukumar. Chapter 7. Name of the chapter is cheese. It is on page number 232. Now, standardization in cheese making, standardization refers to the adjustment of casein is to fat ratio to 0.68 to 0.70. Now, purpose of standardization of milk here is first is that we are regulating the fat content in the dry matter of the cheese, and also second is to have maximum amount of cheese per kg of fat in milk. So these are the two purpose why we are standardizing the milk meant for cheese making. So let us see this problem. We have given 1000 kg of milk testing 4.5% fat, 2.7% casein, and we have to adjust casein is to fat ratio 2.7, and skim milk testing 2.8% casein is also given. So if you see in milk how much fat is there, 4.5 divided by 100 into 1000, that is equal to 45 kg. How much casein is there in the milk? It is 2.7 divided by 100 into 1000, that is equal to 27 kg. And since casein is to fat ratio to be maintained as 0.7, so considering fat as 45 kg, how much casein is required? It is 31.5 kg, that is 0.7 into 45, that is 1.5 kg. So how much more casein is required to have casein finalized? 31.5 kg. 31.5 minus 27, that is equal to 4.5 kg is required. And since we are giving milk, skim milk testing 2.8% casein, this means that 2.8 kg casein is coming from 100 kg of skim milk, and so 4.5 kg will come from 100 divided by 2.8 into 4.8. This is equal to 161 kg of skim milk is required to have casein, total casein as 31.5 kg. Okay, so this way we had adjusted the casein is to fat ratio. Okay, now let us see problem number 11, which is the part of chapter 8. Name of the chapter is condensed milk. It is on the page number 277 to 278. Now this is a numerical on standardization of milk for condensed milk. Now in this we are adjusting the SNF is to fat ratio to desired level as per the legal requirements. Now if SNF is to fat ratio in milk is greater than that of SNF is to fat in ratio that is required in condensed milk, this means there is fat shortage and we will have to add the cream. And if it is reverse, that if SNF is to fat ratio in milk is less than the SNF desired SNF is to fat ratio in condensed milk, then we will have to add SNF, that is we will have to add the skim milk. Okay, so for these two type of numerical we will cover the two cases as I've told you in the form of problems. So here you see problem number 11, which say that we want 9.05% fat and 31% total solid in condensed milk, and we are given milk and cream. So milk 10,000 kg milk is given testing 3.6% fat and 12.5% TS. Cream testing 40% fat is given. Okay, now we have to calculate amount 40% cream that is to be added to have desired fat is to SNF ratio or desired SNF to fat ratio. Now fat in milk is given as 3.6%, TS in milk is given as 12.5%. so SNF will be equal to TS minus fat. TS minus fat is equal to 12.5 minus 3.6 is equal to 8.9%. in milk, and we want that fat percentage in cream which is to be added is 40%. So first we will calculate the SNF in cream. Now this SNF of cream can be calculated from the serum portion. So serum portion in cream is how much? 100 minus 40. This is in cream, and the serum portion, or we say that skim milk in that is skim milk part. If you remove the fat percentage from milk, that is 100 minus 3.6. so the ratio of these two, that is a non-fat portion in cream divided by non-fat portion in milk, this ratio will be equal to the SNF ratio of cream and that was skim milk. That percentage SNF in cream can be calculated by 100 minus 40 divided by 100 minus 3.6 into 8.9. So 8.9 is the SNF in milk into 8.9, that is equal to SNF in cream is coming 5.5%, 5.4454%, because obviously the SNF percentage in cream will be lower as there is 40% fat in it, so SNF portion will be lower as compared to that in milk. Now if you calculate the SNF fat ratio in milk, it is coming as 12.5 minus 3.6 divided by fat is 3.6, it is equal to 2.47. In condensed milk, it is the fat is to the SNF is to fat ratio is coming as, so 31 is the TS minus 9.05 is the fat, so SNF is equal to 31 minus 9.05 divided by fat ratio, that is 9.05 is equal to 2.43. Now here we can see that in milk SNF is to fat ratio is higher than that is desired, so this means that there is fat shortage and we will have to add the cream. Okay, now from this if we write the total fat equation, so how much fat, the total fat, if you write the equation, that is in milk it is 3.6 of 10,000 and in cream it is 40 of the cream, that is 360 plus 0.4 C, and if you calculate the total SNF, that is equal to 10,000 into 8.9 divided by 100 plus C into 5.54 into 100 divided by 100 into equal to 890 plus 0.0554 C. Okay, so total fat content is equation is 360 plus 0.4 C, and if you see calculate the total SNF content, this is 8.9 divided by 100 into 10,000 plus 5.54 into divided by 100 into C. So this 5.54 we have calculated, that is the SNF in cream, and this 8.9 is the SNF in milk. So total SNF equation will be this. So at SNF is to fat ratio which is required is 2.43. So if we put this ratio, that is the total SNF is to total fat ratio, if we put and then calculate the value of 6, we will have 16.6 kg. That is, we will have to add 16.6 kg of 40% cream to the milk to have the desired SNF fat ratio in the condensed milk. Okay, this is one numerical. So here cream addition is required when there is fat shortage, and another numerical is on when fat is surplus, so we will have to add the skim milk. This is the second numerical. So again here we are wanted that is 9.05% fat and 31% total milk solid in condensed milk. We are given 10,000 kg milk testing 6.5% fat and 16.08% TS, skim milk testing 0.1% fat, and we have to calculate the skim milk which is required to provide desired fatness to ratio. Now fat in milk 6.5%, TS 16.08, so SNF will be 16.08 minus 6.5, that is equal to 9.5. Fat in skim milk is given at 0.1%. So if you will calculate fat in, that is SNF in skim milk, so SNF in milk it is 100 minus 6 point, so and 9.58 is how much of the that is skim milk, that is 100 minus 6.5, that is will be the SNF, that is percentage in skim milk, that is 10.25% it is coming. So it is nothing but 100, say if we have removed fat and then in the milk, and we will have the skim milk portion. And SNF, if we considering that here SNF is same and the quantity has been reduced, so since quantity is less and the SNF has been concentrated, so SNF will be higher in this, so it will be 10.25%. Now we calculate the SNF to fat ratio in milk. It is 16.08 minus 6.5 divided by 6.5, this is 1.47, and in condensed milk it is 31 minus 9.05 divided by 9.05 equal to 2.53. So this means in condensed milk SNF is higher, and since SNF is higher as compared to that in the milk, so therefore we will have to add the SNF, that is there is fat surplus, so we will have to add the skim milk. Okay, now if we write the total fat equation as we did earlier, so it is 6.5 into 10,000 divided by plus 0.1 of S equal to 650 plus 0.00x. Total SNF equation if we write 9.58 here and 10.25 here of the skim milk, and then it is equal to coming as 258 plus 0.1025 S, and if you divide that SNF is to fat ratio, if we calculate this divided by this divided by this, we will have 2.43, and if we calculate the value of S, which is nothing but the skim milk in this, so we will have the 6210.6 kg, 6210.6 kg of skim milk that is required to be added in the milk to have 9.05% fat and 31% total milk solid in condensed milk. So this way we are solving such type of problems. Thank you. Okay, and now let us solve numericals on sugar ratio. Now sugar ratio is nothing but the sugar in water concentration. Its formula is percentage sugar divided by percentage water, that is 100 minus total milk solid into 100. This is sugar ratio, and for condensed milk it ranges from 62.5 to 64.5%. Okay, so simply it meaning is sugar in water concentration, and three simple numericals are there in chapter 8 condensed milk on page 280. So first numerical is condensed milk contains 31% total milk solid, so this value is given here, and 43.1% added sugar, so this value is also given, that is percentage sugar is also given, and we have to calculate sugar ratio. So sugar ratio, if we put these two values at 43.1 here divided by 100 minus percent TMS is given as 31, you put this value, you will have sugar ratio 62.5%, which is ideal for condensed milk. So percentage sugar in condensed milk can be calculated from this formula, that is percentage sugar ratio into 100 minus TMS into divided by 100. So if you are rearranging this formula, we will can have this formula also. Okay, now if another question is, if using the same values as above, what should the percentage sugar in condensed milk be for sugar ratio 62.5? Now these two numericals are same, except here we are given sugar ratio and we have to calculate percentage sugar, and it should come to 43.1 as there as in the first numerical. So if we put this sugar ratio, that is 62.5 here, and percentage TMS, which is 31% here, 100 minus 31, and we solve it, we will have 43.1% as was there in the original question. So these two questions are same, just to show that we can, from the one formula we can calculate percentage sugar also in condensed milk, and also we can calculate the sugar ratio. So both we can calculate very easily. This is numerical on sugar ratio, that is sugar in water concentration, simply or percentage sugar divided by 100 minus percentage total milk solid into 100. Okay, let us see one more numerical on sugar ratio. So determination of sugar in milk to give 43.1% sugar in condensed milk. So if we want to calculate the sugar percentage in milk that is required to have specific or particular sugar percentage in condensed milk, how to solve such type of numericals? Say we are giving either we will be given percentage sugar in condensed milk or percentage sugar in milk, and other thing will be asked, that is if percentage sugar in milk is given, then we will ask percentage sugar in condensed milk. If percentage sugar in condensed milk is given, then we will be asked percentage sugar in milk. Okay, so this is very simple, that meaning that if for this type of numerical simple, we know that the ratio of the total solid will be same as root to ratio of the percentage sugar in the milk and condensed milk, meaning that if we have, say here it is given that fresh milk contains 12.3% total solid and condensed milk contains 31% total solid. How much sugar should be added to milk to give 43.1% sugar in condensed milk? Okay, so this is very simple numerical. So here we are given total solid in condensed milk as well as total solid in milk. So their ratio, that is total solid, if I write here total solid condensed milk divided by total solid in milk, this ratio should be supposed to be same as that is sugar ratio. That is sugar ratio is 43.1%. that is percentage sugar in condensed milk divided by percentage sugar in milk. Okay, so this ratio, that is sugar ratio in condensed milk, should be same as sugar that is total solid in condensed milk and the milk. So this ratio should be same. This is the basis for this numerical. Now total solid condensed milk we are given as 31% divided by total solid in given in skim milk is 12.3 is equal to the condensed milk, it is 43.1% sugar, and we have to calculate required percentage sugar in milk. Okay, so percentage sugar in milk, okay, this we have to calculate. So if we rearrange, we will have percentage sugar in milk is equal to 43.1 into 12.3 divided by 31. This is equal to 7.1.2, and this is the answer. So if you want to have 43.1% sugar in condensed milk, then in milk the percentage sugar should be 17.2 depending on the how much concentration that has taken place. So concentration here we see that it is 31 divided by 12.3 ratio concentration has happened, so that's why percentage sugar in milk is supposed to be 7.2% to have 43.1% sugar in condensed milk. Okay. So we have now solved 3 numericals on sugar ratio which are there in the chapter 8 condensed milk, page number 280 to 81. Okay, now let us see 2 numericals which is on adjusting the fat percentage, desired fat percentage in the condensed milk. So these 2 problems are from chapter 8. So name of the chapter condensed milk on page number 287. Now the first question is that batch sample test contains 9.2% fat and the fat desired is 9%. Batch weighs 450 kg. How much water must be added to reduce the fat content to 9%? Okay, so this question is very simple, that we have condensed milk batch which is having 9.2% fat and we have to reduce it to 9% fat. Obviously we will have to add the water, and how much water is to be added, that is the question. So if we see that 9.2% is how much more than 9%, it is 2%. How? This is 9.2 minus 9 divided by 9 is equal to, this is 0.02%. Also n percentage is equal to 2%. Okay, so meaning that batch sample contained that is 2% more fat than that of the desired fat. 2% more fat. Obviously we will have to add 2% of the weight of water to have the desired fat percentage. So 2% means that is 0.022, that is this much, into 450, that is coming 9.9 kg water. Okay, again repeating. So how much is this more percentage than that of this? So it is 0.022, or we can say that it is 2.2% higher. So we will have to add this is 0.022, that is how much, 2.2% of the 2.2% of the 450 we will have to add the water, that is 9.9 kg. Here it is coming. Okay, so this is by logic I have solved it. Now let us see how to solve it by fat equation. So if we have initial fat is Fi and Mi is the initial quantity of the condensed, that is initial that is the quantity which is given, that is 450 kg, that is 450 kg of condensed milk. Initial fat is this much. We want to reduce the fat to 9%, and how much water is to say W water is to add it to the condensed milk. So Mi plus W, this fat equation This way you can write the fat balance, and here from this we can calculate the weight of the water. So this formula, if you rearrange it, you will have this formula. So simply put these values. I mean, initial 450, and then here Fi is 9.2%, that's 0.0922, and here FF is 9%, which is 0.09%, 0.09, and minus 1 is equal to 1.022 minus 1. This is equal to 450 into 0.022 equal to 9.9 kg, that is 9.9 kg. So simply by logic also you can do that is how much more fat percentage is there in the condensed milk as compared to that of desired. So that much percentage of water to be added is 2.2% is coming. You simply add 2.2% of the 450, that is 9.9 kg water to have that desired 9% fat. Okay, this is one question. Now coming to the second question, which is we are giving the fresh milk, so we have no means to weigh the batch, that is condensed milk weight we are not having, so we have to calculate that condensed milk weight from the milk. So if initial standardized weight of the standardized fresh milk is given as 650 kg, fat in desired fat is also given in standardized weight 3.5%, then fat desired in condensed milk is 9%, and final test of the batch actual test is 9.2%. so first we will calculate for 9% how much condensed milk has been obtained, and for 9.2% how much condensed milk has been obtained. For 9% how we can calculate, so 650 into 3.5 is equal to and for 9.2 it is 9 point, that is actually in the batch, this is 9.2, okay, say of x. So from this we will have x is equal to 650 into 3.5 divided by 9.2, which is this, and for desired whatever you desire, that is 650 into 3.5 also here, like we desired 9 into x, so this will give you x equal to 650 into 3.5 divided by 9. Okay, so you desired condensed milk, how much you desire, 252.2 kg, and how much is actually in the batch, this 247.3 kg. so difference of that is means that water required is 252.2 minus 247.3 is equal to 4.9 kg. Okay, so this is very simple problem that you are calculating how much water to be added, and you are not giving the condensed milk. So here again it is written that there is no means to weigh the batch, so actually you don't know the weight of the condensed milk. You have to calculate the desired condensed milk which will come, and also the actual desired milk, actual condensed milk which is there with you, that you have to first calculate. And after calculating that difference, that whatever difference that is coming, that much amount of water to be added to have desired fat percentage in the condensed milk. Okay, now see another numerical which is on standardization of SNF is to fat ratio in whole milk powder. So how to have the standardization of fat and SNF in whole milk powder. This numerical is related to standardization of whole milk powder. Okay, and now let us see one numerical on adjusting the SNF is to fat ratio in whole milk powder. So this is the numerical on the standardization of whole milk powder. So here we are given milk having 6.5% fat and 9.58% SNF. We are given skim milk testing 0.1% fat and 9.61% SNF, and we are asked that how much skim milk to be added to the milk, so that in the final WMP we have SNF is to fat ratio of standard composition. As for standard composition, we say that, let's say we have whole milk powder containing 26.2% fat and 2.8% moisture. So and the SNF we can calculate 100 minus 26.2 plus 2.8, this will give you 71. So 71% is SNF, and fat given is 26.2%. Okay, Now, how much fat is to SNF is to fat ratio is to be desired. This is 71 divided by 26.2. This is coming 2.71. Okay, 2.71 ratio is SNF is to fat ratio is desired in the whole milk powder. Now, how much skim milk to be added so that we can have this ratio? So, say as quantity of skim milk is to be added. Now, if we write the SNF equation on the top, that is here 9.258 in milk, 9.58 so all, because it is in percentage, so everywhere 100 will go out, so we can simply write to 9.58 into 10,000 plus 9.61 of S, that is SNF equation up on the top, and then fat equation, that is 6.5 into 10,000 plus 0.1 into S, that is fat equation on the denominator. This ratio is we have to reach to 2.71. Now, if we solve this equation, we will have skim milk required is 8,603.7 kg, which is the answer. So quantity of skim milk required is equal to 8,603.7 kg to be added into the milk so as to have WMP with SNF is to fat ratio as 2.71. Okay, so this simple numerical, simply once we know that the ratio, we have to calculate the one SNF equation and then the fat equation, and then you put it in the formula. You will have the amount of skim milk required to be added into the milk so that we can have whole milk of desired SNF and fat ratio. Let us see the last numerical from the book Sukumar Day. This numerical is given in chapter 8, and name of the chapter is dried milk. It is on the page number 341 to 342, and this numerical is on calculating the yield of the whole milk powder from given milk with fat and SNF percentage. So the question is, we have 10,000 kg milk testing 7% fat and 9.5% SNF. We have to calculate the yield of whole milk powder. Now, we know that it is the TS in milk which is get converted to the whole milk powder. So if first we have to we also know that we have to adjust the SNF is to fat ratio in whole milk powder. Okay, so as we know that as per FSS standard, we have that milk powder shall not contain more than 5% moisture and should not have less than 26% milk fat. So assuming that whole milk powder to contain 2% moisture and 27% milk fat, so we are assuming that so we will have TS equal to 100 minus 2, that is 98% TS. And if we calculate the percentage SNF will be equal to 98 minus, because this TS minus 27, that is equal to 71%. SNF will be there, and so we want SNF is to fat ratio in whole milk powder to be as 2.63. 71 divided by 27 is equal to 2.63. So first we have to calculate that how much cream is to be removed to have the fat percentage in standardized milk as 3.5%. So that will do by Pearson square method. So we are given 40% fat cream we are having, and 3.5% fat in standardized milk. We have to have 7% fat, and by Pearson square, that is this is coming as 3.5 and this is coming as 33. So 3.5 divided by 36.5 into 10,000. This is coming as 9580.9 kg of cream to be removed. And if you calculate, if you subtract 10,000, that is, we subtract 10,000, that is 958.9 from 10,000, we will have 9,041.1 kg standardized milk will be there from 10,000 kg milk, because 958.9 kg cream has been removed, so we will have 9041.1 kg. Now if we see the percentage as one of instant milk, that we have to maintain the ratio 2.63. so if we multiply it by fat by 2.63, then you will have the SNF. That SNF is, that is 9.21. So percentage TS, that is fat plus SNF, which is coming as 12.71. in standardized milk, and this is how much of the TS. How if we calculate 9041.1 into 12.71 divided by 100 equal to 1149.1. So this much TS is there in the standardized milk, and say we are assuming that 1.5% loss is there in total during manufacturing. So if we calculate 1.5, it will have 2 kg, and TS then it will be 131.9 kg, that is be used for production. Now since 98%, so this whole TS will get converted to whole milk powder, and this 98% is equivalent to how much? This much. So how much quantity of whole milk powder that will be obtained? It will be 115 kg, that is 1131.9 divided by 98 into 100 equal to 1155 kg or equivalent, and we have removed 9.9 kg of cream that has been removed. So this is a numerical in which we have calculated the yield of the powder and maintaining the ratio by maintaining the ratio of acid, fat and SNF. So this type of problem are usually asked, and a simple way that if you are considering that there are no losses, and you have a simple way you want to calculate that how much whole milk powder will you obtain from 10,000 kg of milk. So you because we know that all of the TS is getting included. So if you add the TS, that is TS is 5.997, 16.5 is equal to how much of the whole milk powder has obtained, say of desired TS, say 98%. So this way you can calculate the value of X. This is the in one step how to solve it very easily. So we have seen that TS is only converting into the whole milk powder. So the proportion will be same. So 16.5 into 10,000 equal to X into 98. So X, we can have the 10,000 into 16.5 divided by 98. So this way also we can calculate. But if you want to calculate step by step, that if you are maintaining the SNF is to fat ratio, and then how much cream to be removed, first you are calculating, and then how much TS is that is there in the standardized milk. From that, if you calculate the yield, this way you have to calculate. So again, if you want to calculate quickly, so if you assume that whole milk powder contains 2% moisture, TS is 98%, and if you calculate the SNF, that is coming as 71%. Okay, so SNF is to fat ratio is 2.63, and say if we have standardized milk is given and 40% fat is cream is given. So from that we have to have the 7% fat. Okay, so let us here it is small correction. So from the 40% fat in cream and 7% fat in milk, which is we are given, so 7% here, it will come here 7% fat in milk. We have to have the 3.5% fat, that is standardized milk we have to have. So 7 minus 3.5 is 3.5, 40 minus 3.5 is 36.5. Okay, so 36.5. So 3 their ratio, that is 3:5 is to 36.5 divided by equal to C by 10,000, that is cream that is removed is 958.9 kg. This is how there is small mistake here in the Pearson square in the book. So here we can correct it. That is from 40% fat cream and then 7% fat in milk given, we have to have the standardized milk of 3.5% fat, and SNF correspondingly to have the fat is to SNF is to fat ratio 2.63 as 9.21. So this way we are solving this type of problem and are mostly asked in competitive. Okay, with this we have solved all the 19 numericals which are given in the book Sukumar Day. Now these numericals will be readily available to you for revision and will definitely help you to solve similar problems which are coming in the competitive exams. So as told in the first initial start of the class, that these numericals are mostly asked in the written examination conducted by mostly the cooperatives in India as a part of their recruitment process. So you must have full command on these problems and practice more problems related to the one which are covered in these two videos. Thank you.